Good morning, students. This is Dr.GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today, in this session, I would like to explain how to solve the combined load problems. So take one problem. Here, the given problem, a shaft as shown in a figure is subjected to a bending load 3 kilonewtons and pure torque of 1000 Newton meter and an axial pulling force of 15 kilonewtons. See, your axial pulling force is 50 kilonewtons and the bending load, this is not on the direct load, the given load is the bending load and the axial pulling force is 15 kilonewtons and torque also acting, this is the 1000 Newton meter. So he has asked in this condition, in this situation, calculate the stresses at A and B. What are the stresses at A and what are the stresses at B? So it means what are the stresses at upper portion of the shaft, upper fiber, and what are the stresses at lower fiber. When it is subjected to the combination of these loads. Here one is bending load acting, bending moment, and then the torsion, and then another one is direct pulling force. So that is tensile load acting. The given shaft diameter is 50 mm diameter and length is 250 mm. So for this problem, we need to calculate stresses. So first of all, so write down the given data. The given load is 3 kilonewtons. The torque is 1000 and the load is 15 kilonewtons. So this is the pulling load and then the length is 250 mm and the diameter is 50 mm. This is the cross section of the shaft. So find out the cross sectional area of the shaft by using empirical relation. Area is equal to pi by 4 into d square. So here given shaft is solid shaft. So find out the cross sectional area of the shaft. Suppose if the given shaft is a hollow shaft, then in that case you need to use outer diameter and inner diameter. But here in your problem and as shown in figure, the shaft is solid one. So directly substitute the given diameter in this equation, you will get area. So now the tensile stress due to axial pulling at points A and B. So they are the tensile stress due to the pulling load. So direct tensile stress will be occur. So what is the tensile stress? The relation, the load upon cross-sectional area. So substitute the direct load 15 kilonewtons and area already we have calculated in above step. So that is 1964. So we will get 7.64 megapascal. So after that, calculate bending moment at points A and B. So here 3 kilonewtons load is bending load is acting on a shaft at one end. So that's why the bending moment will be induced at points, fixed points at A and B. So calculate the bending moment, load multiplied with the distance. So load is given bending load is 3003 kilonewtons, convert into newtons, that is 3000 and the length of the shaft is 250 mm. So you will get a bending moment at A and B. And calculate the tensile stress due to axial pulling at points A and B. So already we have calculated in above step. And then bending points at A and B also we have calculated. So find out the section modulus for the shaft. that is Z is equal to pi by 32 into dq. So pi by 32 into d, diameter already we know 50 mm given. So substitute values in this equation. So we'll get section modulus. After that, find out the bending stress at point A and B. So already bending moment already we know calculated. The bending moment induced due to the bending load, the given which has given 3 kilonewtons, and calculate the bending stress at point A and B by using the bending equation. Sigma B is equal to m by z. Z is section modulus of the shaft and m is bending moment. So substitute those values in this equation, you will get the bending stress. This bending stress is tensile at point A and compressive at point B. So always the upper one is upper portion of the shaft is tensile, and the nature of the load in the bending stress at point B is compressive. So what is the total resultant tensile stresses at A and B? At sigma A, so at A point, direct tensile stress acting, and so due to the bending load, another bending stress also acting. So the combination, the sum of these two loads, two stresses will give the resultant tensile stress at point A. They similarly find out the resultant compressive stress at point B. So find out the resultant tensile stress. One is sigma B, the calculated 61.1, substitute in this equation, and then sigma naught, that is direct tensile load, tensile stress, that is 7.61. The sum of these two stresses will give 68.74 megapascal. So this is a resultant tensile stress at point A. So similarly, the resultant compressive stress at point B. So find out resultant compressive stress. So here compressive nature is lower one is the lower one compressive load is nature of the bending moment. The bending stress is compressive. Clear? So that's why use the negative sign. So here sigma B minus sigma 1. So one upper one is tensile and lower one is compressive. For compressive stress, use negative sign. So 61.1 minus 7.64. You will get 53.46. So we know that the shear stress at point A and B due to the torque transmitted, that is due to the torsion. And in our problem, as shown in figure, the shaft subjected to torsion also. Clear? So that is that's why some shear stresses will be induced in the shaft. So find out the shear stress. Tau is equal to 16T by pi d cube. So already we know the torsion is equal to pi by 16 multiply with the shear stress multiply with the d cube. So find out the shear stress value from this equation. We will get 16T by pi d cube. Clear? So this one is 16T by pi d cube. So substitute torsion value and d value, you will get shear stress. Now stresses at point A. So what are the stresses acting at point A? Maximum principal or normal stress at point A. Due to the already we have studied in principal stresses, due to the combination of torsion loads and bending loads, so some principal stresses will be occur. So that is the maximum principal stress at a normal maximum or minimum principal stresses are also called as normal stresses. So what are the maximum stresses at point A? Need to calculate by using principal stress empirical relation. Sigma A maximum is equal to sigma A by 2 plus 1. Sigma A means here at point A, that stresses, what are the stresses, the resultant stresses acting at point A. So substitute those values in this equation, you will get the maximum principal stress. Similarly, the minimum principal stress at point A. So use negative sign. Only difference is here in the first case is positive sign, and second one is use negative sign. You will get minimum principal stress. So this is see at point A, the nature of stress is tensile stress. So that's why positive value, and the nature of stresses at B point at B point is compressive, that is a negative sign. So use this these signs for this calculation of maximum and principal stresses. So we will get, so that point A 18.93. So this is a negative symbol, so the compressive nature. Similarly, calculate the maximum shear stress at point A. So half multiply with square root of sigma A square plus 4 tau square. So you will get 53.3 megapascal. Similarly, at point B, calculate maximum principal stress at point B. Clear? And you will get 75.46 megapascal. And minimum principal stress is at point B. And maximum shear stress at point B. You will get 48.73 megapascal. See, in point B, the nature of stress is a compressive nature. So, the compressive stress here need to substitute in this equation. Clear? And then, so have calculated all stresses. What are the stresses acting at point A and point B? What he has asked in a problem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.